Right guys, we're going to start back up again with a new project piece. Scooter we've got in for refitting. I'm going to keep as a personal scooter because it's a bit special. It is a Tech Life X9, also known as 0X11 and probably a few other names. She's a big girl, 72 volts, peaks to 7,000 watts, 6,000 watt standard I believe. Yeah, she's very chunky. This unit came without the deck plate, so that's a problem to overcome. And this video I did start shooting yesterday and run into a problem, so we need to leave off from there. That video was scrapped. I've still got it. I'll probably put a few clips in it. It involves the controllers I'm about to explain now. So anyway, I'll actually show you some pictures and video footage of the actual scooter we're working on. We're going to go a bit over the board with this one. We're going exposed battery top so we can see the work. We're going with the Ant Plus BMS 17 series. We're knocking back the 72 volt battery to 70. I'll explain why in a minute. We're going to put a Perspex 5mm clear deck on top so we can see all the insides, as well as the BMS, the two controllers, the wiring, so everything has to look impeccable. Addressable RGB lighting. Yeah, we're going to go a bit crazy on this one, just for fun, something for YouTube for the next couple of days. Let me just switch the cameras back, and we'll see what we got. Right, first off, the reason why this video wasn't sent out yesterday, I did start making it, I was 45 minutes in, and something tragic happened involving these controllers. Bought these controllers off Amazon from a seller. We'll get down to the UK distributor, where they sell them from, etc. in a second. Usually I wouldn't, but in this case I think we got them. So I was halfway through the video yesterday. I will have to zoom in. These are 72 volt 2000 watt controllers. Controller 1, controller 2. Funnily enough and luckily enough, controller 1 arrived the day before controller 2, which means yesterday I had a chance to start filming on just this one controller. I got as far as taking the PCB outside of the board because we're going to remove some wires. I'm also going to show you how to install one of these generic controllers. This doesn't just cover this model, this voltage. This is pretty much standard for all the cheap Chinese controllers. Most manufacturers just come in, snip the wires, attach LCD cables to make them compatible. We'll also be doing that because this is a Protocol 2 controller. It's an old school Kiwi from 2005. I know I'm going fast. We'll run into it. Don't panic. Bottom line is an S866 display, a QS S4 trigger display, and a handful of others will work with this controller. This controller is £32. You can get them for as low as 23 for a 48 volt version or a 60 volt version. I've installed these on Kaabo Wolf Warriors GTs before they brought out the GTs with sine wave. Yeah, they are not bad for the money, except for some reason the higher voltage 72 one, which we've got in front of us, has got a few issues, which I'll explain. We got a lot to run through. There's going to be a couple of videos, including a live stream to wrap up some questions as we're installing all these wires. But we need to just rewind slightly first back to the story. So ordered the controllers, one arrived the day before, lucky touch. Opened up this controller yesterday, straight off the bat inside's 80 volt capacitors. As I'm talking about it, we may as well go through the motions. We'll also open up the new one that came today. In fact, we'll do that as well. As you can see, both identical, both from the same retailer, same importer, Komodo Electronics. They're the same thing. Now I gotta remember which one I just took out. Right, we'll stick one to the side. So anyway, yesterday I was shooting the video. I was taking out all the screws, explaining what we're going to do over the next couple of videos. So as I'm running through, I realized as I opened this up inside, the PCB board has 80 volt capacitors, which means the 72 volt battery is never going to work on this, not without blowing them. Simple reason is the 72 volt battery charges up to 84 point odd volts, give or take. Give me a break, it's late at night. So yeah, as soon as we pass more than 80 volts through these capacitors, they ain't the best to start off with, and they're just going to pop themselves. So that's that over. Next, I check the MOSFETs out, just in case maybe the wrong caps were fitted. The MOSFETs were model HY3208P. The data sheet, let me just show you the data sheet for these MOSFETs. Right in front of me, as you can see, if we look for it in the description, they are rated for 80 volts, 120 amps output. Forget the rest, it's important, but not to us right now. And we probably won't go over that because there's no need. So anyway, 80 volt MOSFETs. So again, as soon as I plug a fully charged 72 volt battery into this, they're cooked as well. Fabulous. Also on the PCB board is a selection pin. What that does is it lets the manufacturer determine the low voltage cutoff point of the controller. All that is in short, it's called the LVC. It stops the controller from sucking the last bit of energy out of your battery to the point where your battery can't be charged again by its normal charger. Standard on every controller, 48 volt, low voltage cutoff point is 39. They've all got the different voltages. I'm not going to run through them all because that's boring. So anyway, let's get this board out and I'll show you exactly what I seen yesterday on the other one. Last screw. So just as yesterday, underneath, straight off the bat, let me see. I'm never going to get that camera angle. I'll have to upload pictures. Unless I've got a macro lens, 2 seconds. Let me just see. Might have as it goes. Okay, switch the lenses. Good idea, son. Let's find one of these caps. Right, let's get on the back side of this. Let me find the markings myself, and then I can show you. There you go. 80 volt capacitors. 1, 2, 3, 4. Let's go back in there. Low voltage selection pin. Right by my finger. It's currently set to 60 volts. It can also be set to 64, 72 and 80. But as you can see, there's no point setting it to 72 or 80 because these caps, these MOSFETs are gone. This one does come with different MOSFETs than yesterday's version. So that will be interesting. There's StarTech, I do recognize them. Bear with me a second. We will also check the data sheet on them. Chances are they're the same rating. It's just what they had in the factory, basically. So we've got an S80. Sorry for this being boring, but it's important. N10R MOSFET. Brilliant. Let's plug you in so you can see the screen. Back to the web browser. So the MOSFET's inside this controller. Dun, 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 dun. Again, 80 volts rated for 100 amps only. So they've knocked 20 amps off by installing these straight off the bat. Same controller, different MOSFETs. So again, same problem. Can't be used. What else have we got? This video is going past the manufacturer as well. And Amazon, because they sent me 2 free units to review. Lovely. Workmanship, I'll be honest, it's £23. If you've got a soldering line, you can touch up. If you haven't, they work out of the box, but it's £23. What are you expecting for workmanship? Although what I will say is manufacturers, without calling out some big ones, let's see what we've got on the side. Standard Kugoo M4 controller. I know it's not the expensive one. Exactly the same keywin model, workmanship exactly the same, no good. I can pull out a dualtron mini motor one as well. Workmanship, let's not even go there. They're just, let me see, 20, yeah. Minimoto buy £29 controllers, take them out of their metal aluminium housing, insert them into their own custom Minimoto housing, then charge you £125 per unit. Lovely markup on that. I've also got a video of me doing that as well. I'm running them on a Wolf Warrior, so that's fun. So anyway, what have we got to work with? So this is the problem I encountered yesterday. So straight away, video scrapped. Can't install this on the 72 big Y behind me. It's not going to happen. So next plan. Spoke to Amazon. Refunded me for both units. I've got a decent account with Amazon, as you can imagine from the repairs. I order enough items off them direct. Yeah, so I've installed more than 100 of these in the past 6 months. So they refunded me without question, then asked if they'd send me another few units to review from other sellers, just to make sure, because this is not just mislabeled and, oh well. It's not you ordered the blue toothbrush, they sent you a pink one. What are you going to do? Close your eyes when you brush. Makes no difference. This is a hazard. I know it's a hazard, it's fine. The problem is, I was making a YouTube tutorial yesterday how to install one of these genetic controllers on your 72 volt system. Now, if you would have bought the controller I told you to buy, you would have blown yourself up. And I've got to take some sort of responsibility for that, because I've gone ahead and shown you how to do it. So I'm glad I caught this before just plowing away. So that's the reason basically I had to contact them. That's the reason I've had to contact the manufacturer. Hopefully they'll rectify the issue in some way, because they can't ship these out. I know Amazon's put a pause on their account. But yeah, again, if you try to copy what I was trying to show you, it's going to end bad for you. It's going to make me look like a plonker. And probably that's where the buck's going to stop, because you wouldn't think further down the line a big manufacturer would make this big cocker. So there you go. Enough of that at the moment. So now for what the plan is moving forward. 72 volt controllers. I've got no faith in getting one off Amazon. Not until I see some review samples and I can check them out. But I've still got this scooter sat behind me. So we're going to take the 72 volt battery, knock the last 3 rows off, take it down to an odd size battery, which is going to be, I think, a 68, which is 17 in series. I've checked my math on that, but we're going 17 in series. Yeah, it's a bit of a downside. We can always add it back on later when decent controllers either come up, or I at least get my hands on one to review that I'm confident in. And then that can always be added back on. Do a video on that showing you that, no issues. Silver lining to the problem, we can use a smart BMS, an Ant Plus, and I can run through all the fancy stuff and install in one of them. Now, the difference between the 72 and me running at 68 is speed. Quite frankly, I'm not going to go past 40 anyway. Don't want to. It'll still be capable of like smashing anything on the road, to be honest. But I've rid of 72 volt system. I've rid one of these when they're fully working. You don't want to go full speed on one of them. It's not enjoyable. So yeah, I'm quite happy to knock the system down, keep the 32 amp hour LG battery, take it down a peg, install a smart BMS for a bit of fancy, something to look at through the Perspex deck I'm going to put down. Battery's exposed on top. Obviously it's screened off with a clear screen so nothing can touch it. It's still protected. We're not flying that loose on this one. So that's the plan with that. Then we can use these controllers, the 2 of them. Then they can be installed, then we can carry on, make the video, ride a scooter in 4 or 5 days time. So first thing we need to do is explain what these wires do. Set this to, what are we going to run it? Let me see. I think we'll set it to 64 volts. We'll move the pin. Yep. We'll move this pin that I just pointed out earlier. That's on the 60 volt marking. Camera angle's terrible. I will zoom in when it gets down to soldering and we'll get in there. But we're going to desolder the 60 volt jumper pin there, move it down to the 64. All that's going to do is set the low voltage cutoff point to a bit higher than we're running a 60 volt battery, which is great. But we're using a smart BMS as well, so doesn't really matter. I could leave the pin there if I wanted to. I think it affects the wattage and amp draw. So we're going to move it anyway. But because I'm installing the smart BMS, I can determine when my battery's going to cut out, at what voltage, how many amps I want it to give out. We're going to have a bit of fun with that. And I'll show you a place to get one really cheap for less than like 40 bucks. And they're really fun. And safer than the normal BMS. It gives you a lot more confidence in charging up your device at night in the house. So, first thing to do, because we got a lot, run through the wiring. because this scares people. These controllers, first of all, let's just run through it. We may as well be thorough. This is the controller. As you can see, it's a D-color 72 volt 2000 watt brushless speed. It's pretty generic. It's a Keywin model, just FYI, from 2015 with open source firmware from GitHub. I think it's Stan Koch's firmware is on here. You could change it yourself, you can do whatever you want. This one in front of us, as you can see, doesn't come with an LCD. That's what makes it so cheap. That's also what makes it so undesirable. You can't add nothing pretty to tell you your speed. In my opinion, you don't need your speed to be told to you because you're not looking at your clock when you're doing 50. If you are, you've pretty much crashed at that point. So, but some people like a speedo. And we got the benefit of having 3 gears to pick from and some stats to play with on the LCD, etc. But this one out of the box, no LCD connector, no LCD, not compatible, stated in the description. Truth be told, it is. Connections not added. We're going to do it ourselves and mate it up with a £20 LCD. So there's no worries there. Did they give a wiring description? No. As always, I'll show you the markings on the wires and what they've sent us out of the box. But there is no wiring description for this. What else have we got? That's about it. So out of the box, what have we got to tell us how to wire this up? We got symbols. Now you can use Google Translate on your phone, bundle of laughs. Or we can run through them so quickly, you'll have them memorized by the end of the video. That's how easy it is. Set exactly the same wiring for this type of controller. A 48 volt. Let me see. Let's pull up a 48 volt controller. Exactly the same wiring for this one, for this one, for this one, for this one. You see where we're going with this? Every generic controller except for these, which is a KT controller. We like to stay away from these because they're very picky and fussy and expensive for no reason. Wiring is the same on all of these. Look, there's one of the controllers we're going to install now. This one comes with an LCD and the connection pre-installed. For the price you pay, yeah. But yeah, this wiring tutorial, if you will, that's part of this, I suppose, is going to be for pretty much every one of these controllers. What we got here, 48 volt 1000 watt controller, 33 quid. I can vouch for that. Stick that on your Kaboom Mantis. That's a bundle of laughs. What else we got? These are great. Variable watt controllers, 48, 60, 64. That's quite expensive. Believe it or not, I've used these before. They're 48 volts, 350 watts. I've turned them up to 800 watts and slapped 2 in a dual drive Mantis. That was a ball. Let me see. That's about pretty much every controller. One of these, one of these, one of these. These, no. These are KT controllers. The way I can tell is by looking sometimes at the outside of the case. Cheap, 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 not cheap. It sounds stupid, but it's been 3-4 years now. Pretty much spotting from a mile away. So back into this we go. Wiring. Let's go through the basics. Big black, big red. Negative, positive, straight to the battery. Nice and easy. We're going to use them. We're also going to cut out the ones we don't use. Desolder them from the board so we're not left with mess inside the deck. This one has to look pretty. So we've got our power. We've got our phase. Blue, green, yellow. Every 3-phase motor has got this. Some 3-phase motors just run off phases and don't use the Hall sensors. Quick explanation. One sine wave, one square wave, or trapezoidal they call it. There's also the Holy Grail, which is FOC, Field Orientated Control. That's another subject altogether. Anyway, way to tell them, if you're using Hall sensors, your scooter pretty much starts off pretty smooth, sounds like a Xiaomi. Winds at a sweet pitch, and off she goes, slow acceleration. If you're not using Hall sensors, your motor grunts. I call them grunters. They start off with some high torque, and off they pop. That's mostly your kaabo G boosters. There is a few Kubo G booster side, but there's also a few kaabo warriors running with just holes. They always burn out from the gold connectors, gold plated connectors, by the way. Common problem. So anyway, that's that. We won't be using hole sensors on this scooter. The motors simply don't have holes. Reason being, hole sensors are temperature sensitive, and on the bigger devices, they tended not to fit them because they just fail. It's pointless. On the controller, you notice it says 2 modes. That's what that means. It can run one mode, hold, using the sensors, and it can run the second mode, square wave. So if a sensor fails or you don't have them, automatically kicks into square wave mode. What a grunter. So we're going to use them too. Keep them in hand. What else have we got? Let's get to the easy stuff first. Throttle. Black, green, red. Always the same. 5 volts ground. Signal back from your throttle hole sensor as you twist it. The voltage goes up. Sends signal to the controller. Increases the amps to the motor. Spinny, spinny. You get the point. We're going to use this on ours. I might fit a twist, trigger, thumb. Don't know yet. Versatile. We're going to keep it. Next, we will go through, let me see. Constant power alarm when a scooter's off, even if you've got a key and it's not turned. This is always live. That's always a ground. That's always full battery voltage. This is used for alarms, and it usually joins up with this block here. You can get a key immobilizers on Amazon, cheapest chips, 12 to 16 pounds. Install them yourself. The connectors are always pretty much the same. We're not going to use the alarm feature, so that can go. All it does is ground the yellow wire to the phase, which stops the motor from rotating. Even if it's not turned on, they're trying to roll it down the road, the magnets lock. Good feature, but you can still pick it up if it's a small scooter. So we're not using that, but we will be using the constant power. Because don't forget, we're going to plug in our LCD connector and our own LCD. So we're going to need the red, which is constant power, to go into the red of our LCD. We're going to need the black, which is a ground, which goes into the black of our LCD. So we're going to keep that. Next is our ignition wire. This wire needs to receive full power from the battery to turn on this controller. That's the easiest way of putting it. You can do it with a switch from the main battery power red to the ignition. You can run a switch through there, click, on goes the controller. How we're going to use it is to join it onto the yellow, which is the power return. So when we push the power button on our LCD, the power that's always coming through the red line goes up to the LCD, comes back down the yellow line, turns on the controller. So now we've got our controller wired up so we can turn it on and off via the LCD. The only last 2 connections we need is the communication ones, receive and transmit. We'll get to them shortly. One of the wires we got then in this mess. Let me just rearrange this back. So that's what we're keeping. Next, we got our braking. Why not? Black and white. When joined together, it cuts all power to the phases, which stops the motor. Even if you're smashing the throttle, it'll cut. You got your brake levers. You see the brake cable coming out. You've also got the extra cable with a wire. That's why when you pull your brake, a switch is pushes these 2 together, which cuts it out. We will be using this on this vehicle, but this has hydros fitted. We're going to have to 3D draw and print our own brackets to hold the magnets, because I am not gluing nothing on this. It's too nice. So we're keeping that one. Our key pile's looking big, mind. Next, we've got our manual gear switch. Interesting. Dun, 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 dun. Brown, black and blue. Manual gears. All this does, it lets you put a 3-way switch on the handlebars. I prefer the left hand side, so you never got to take your thumb off the throttle. And when you ground the brown to the ground there, it goes into first gear, which is low. When it's left open with nothing, it's in middle gear. When you ground the blue with the black, it sets itself to high gear 120%, which is gear 3. You can use this if you want to do manual switching without an LCD, which is preferable if you're going to throw your vehicle around. LCDs are pretty delicate and temperamental. So if you're smashing it around and don't require LCD, manual switching. It's lovely. We might use this, but for now I'm going to say no, because we can change gear using this up and down. Sometimes it's best to have a switch in front of you to throw with your thumb manually, especially if you're holding on at speed than trying to hold a button down. And I like a switch to dump, and I know what gear I'm going into, but we're not using that right yet. What else did I leave us with? The 2 white wires. Let's get them out. Single connector wires. These are called training cables, learning cables, intelligent training cables, many names. Basically, your vehicle's turned off. The first time you ever set this up and install it, these two are connected together. As you turn your vehicle on, the wheel will rotate automatically in a direction. Make sure your wheel's off the floor. If the wheel is rolling in the correct direction, while it's rolling, you disconnect these. Controller now knows which direction to rotate the wheel when you do the throttle, no problem. If your wheel is not going in the right direction, you unplug these, you wait for it to stop rotating, you plug them back in while the vehicle's still on, and it'll rotate in the correct direction. Then once you unplug them again, you never plug them back in, you never use them again, they can disappear. The only reason we're not going to remove these from the PCB is it has to be done when everything's powered up, and I'm not taking this all apart again to remove 2 wires. We'll clip these at the base and heat shrink them. So we're going to need them. Let me see, what's this one? Cruise control. When grounded to grey, whatever speed you're at currently activates cruise control, so you can take your hand off the throttle. The vehicle speed is already determined. You stay at that speed till you throw the switch. Job done. Don't like this, because if you forget to throw the switch, you panic, you think the throttle's not responding. What do you do? What do you do? Jump off? Oh, I've done that. That is not fun. Kaabo Mantis run away from me going downhill towards a river. And needless to say, I threw it into the barriers and jumped off about 15-20 miles an hour. It did not survive. Where else we got? Ground we can always use. Yep, just a regular old ground. And that could be used for lighting, I suppose. Many options there. This one, the purple wire, I don't agree with at all. This is for, they call it an instrument line. Problem is, it doesn't communicate in any fancy way. What it does is go from 0 up to 28 volts the faster your scooter goes. And it goes to an old school instrument line like off a motorbike, and the speedo goes up. Problem is, if this plastic clip slips down and the metal inside is exposed to your frame, well, that's voltage going straight to your frame. What if this little black one's crushed your frame as well? Then you've just shorted out your controller and you're having a really bad day. This one gets removed. This one they call a low-level instrument line. Now, this would suggest to me it goes to... It doesn't. So where it goes is going to be funny. But this should be to the RX or TX on the board, which they won't label up on one of these controllers because it stops you from having the ability to install your own LCD. But I'm going to show you where these pins are. All these I have mapped out. All the markings, like A2, L, X, DS, regen braking, K1, K2, F3, F2. I've got them all mapped out, what their feature does, how you can just switch the feature on and off by grounding each symbol to engage a feature. There's plenty these controllers do. So that's going to be fun. But this doesn't go where I think it goes. This goes somewhere else. So that's going to be investigation. High side braking. That's the opposite. No. High side braking is the opposite to low level braking. Low level braking, you ground the circuits to cut the power. High side braking, you open the circuit which gives the power which cuts out the brakes. Very confusing. Never use it. Forget about it. We might keep the 12 volt line to run some RGB lighting off though. So we got options. Because that is 12 volt dependent. And we have some more mystery meat, which is orange. It goes to Q. Let me just check Q on my schematic. Dun, dun, dun. EScooter's control function. That's another cruise. How's this one enabled? We'll get around to that at another time. That's another video. But needless to say, we'll go through all of this. So, in short, we're keeping this. We're ditching that. We're going to remove the colour and put some black sheathing over all of this because it throws the eye off and we're going to be able to see all of this. I was thinking about leaving the cases off this so we could see it through the deck. Only problem with that, let me switch the camera back a second, is you actually need the case because it cools the MOSFETs. So that plan was scrapped. But we are going exotic with this one. Okay, what else we got going down here next? Is there enough time to do something else tonight on this? Let me see. What do we need to do? We need to wire this LCD up. Soldering iron's on. We might as well go for that, I think. Let me see. Right, on this board, let's start getting some secrets out the way. If you ordered this with an LCD, it would be labeled different in two places. And that'd be where your LCD connects. I think that's to tell the manufacturer or the person who connects these LCDs, I'll sort the camera out now, bear with me, how to connect up LCD or adapt them. Alright, that did not help at all. There you go. The workmanship is terrible. But anyway, we're going to sort this out. LCD connector time. This is a generic board. This goes for all of the boards that I showed you in the Amazon listing just then. I'm going to use a Stanley blade. No, I won't. That's a bit too unprofessional even for me. I'm going to use solder. Right. Let me find them myself. First of all, F5. Dunk dunk. That's your RX for your LCDs. Any protocol to LCD. So there's one cheat out the way. So we need a wire going into this pin. Take out to our LCD. And that's going to be our green wire. That's a bad color next to blue. But anyway, that's going to be our green wire. That's going to communicate to the LCD. And tell you what speed it's going, what gear the controller's in, how many amps it's drawing, all the fun stuff. So then we need the TX, which is to transmit from our LCD back to our controller. What that's going to do is tell our controller whether we're in gear 1, 2, 3, what our speed limit we want it to be, how many amps we want to draw, what our wheel size is, loads of fun stuff. That is F4. But if you bought one with an LCD pre-fitted, you paid a lot of money to have a wire tapped on F4 and F5 running out of the silicone. Your preference. For the fun stuff, some people like to do this themselves. So we need a wire there and there. Now we could come from this side of the board. Good luck with our mess. Or we can sneak two cheeky ones. One there and one there. We're going to go for the sneak two cheeky one option. I won't plan on doing this tonight, so excuse me. Right. But I think I got enough stuff around me to get this at least wrapped up. He said confidently until he can't find his cutters. Oh, here we go. We're back in the game. Let's just get back to this. Let's start stripping some of this down. So while I'm stripping some of this wire down to get myself two good clean wires, we will talk about LCD protocols. The boring stuff. It's quite fun actually. Let's see. The only one that's special, crazily enough, is a Xiaomi. They did actually research and design and develop their own BLE boards alongside 9bot parent company, blah blah blah. But they're special. Every other display ain't. It's a copy of a copy of a copy. Every Bafang display is labeled something else. It just talks a different language to its controller. Every generic controller, you get them in 3, maybe 4 types. You get a Keywin style controller with this type of PCB mold backing, which I've got the manuals for. You also get, let me pick my brain here, an Infineon style controller, which is more like what's in this box. I'm not going to open that up tonight. You get a, let me see, Infineon Keywin, a KT, which is the ones that usually comes with the big displays on the kit bikes, really overpriced for no reason. They're not much fun. Got the board markings for them. There's a Lishi controller. They're pretty cool. You can reprogram them to FOC. They're a bit complex on the back. Got the board markings though if needed. Yeah. Anyway, we're on a Keywin. That's controller talk. All them controllers only talk 2 languages. Protocol 2 and 5S. I think the other protocol's called, yeah, 5S. So they only talk them. And then all the LCDs themselves either talk one or the other protocol. There are a few LCDs, triggers and displays like this one that you can set in the P20 menu here what protocol you want it to talk. That's a benefit in our case, because if our controller doesn't talk one, chances are it talks the other, which is what we want. Let me just wet these up a second. Can we go in? Let's try to zoom out. We're running a new camera, so don't blame me. I'll see if I can clean it up. Probably not. Looks like a potato. But it's what we're working with right now anyway. So it is what it is. It will get better, that's all I can say. F5. Let's wet that up a second. Done. F4. F4 is bridge to another pin. Let me just make sure it's not being connected to anything. Nope. F4's our lady. Spot on. Let's make that wet as well. Then we've got F4. Let me just tin our wires a second. This is nothing fancy. Just gonna get some wires on there so we can get them outside of the controller so we can connect up this display. All I'm gonna do is sneak these two in. I'm gonna go buy myself 2 little slots there. There's one, and in, and maybe 2. There's 2 over there, and in. Nice and easy. Now I need to come to my other side of the board. Please note I haven't plugged this controller in at all since moving it from the box, and I tested the capacitors to make sure there was no current in them. Once you power up these for the first time, they will retain voltage. So you don't want to be doing this while it has voltage. You will have to drain the capacitors down. I hate the fiddly bits, I'll be honest. There's one. We have one. There's the other one go. There he is. Let me just get the other one up. Yep. We have 2. Right, that's all we want for now. Mental note on which wire we're putting where. Make sure the wires are not too long. We don't want them bridging over from one to the other. I mean, look at the size of that. We cover half the board with that. We don't want that in our lives. Let's cut it right down. I wish I had my clips on me. Right. Let me re-tin these again. Where's the good solder? Because this is crap. One. Yeah, that solder was crap. Right. Let's go with white on F5, which is our RX. We can still take a lot more off that as well. A bit embarrassing, if I'm honest. Right. Let's just get that on him. One down. And we're going to stick the orange onto the other. If you wire these up and forget which way RX and TX is and you wire them up onto the LCD, no need to cry, nothing's going to break. You're just going to have to switch the wires around, that's all. Not inside on the controller, outside. So it's not end of the world, don't panic. Important thing is to get the two wires on F5 and F4 on the back of this Keywin controller, which is like pretty much every other cheap one. I'm just going to give away it all, you know. Right, that's on and done. Visually inspect it. Make sure it's not touching anywhere else. That camera is shocking. Why am I zooming tonight? Is the light level too high? Bear with me. Sometimes the light level throws it all off. Let's try that. Hey, not pretty, but there you go. Make sure she's not touching anything else, because that'd be disastrous. Nope, just F4, F5. So now we got two wires coming out the end. RX and TX. Ready for our LCD. We are connecting this LCD up. Let me tin these wires a second. Jobs are good. If you're soldering as well, usual H&S rules apply. Mask, evac system. Don't do as I do. Gotta say that because for safety reasons, and it's going on YouTube. So anyway, we've tinned our wires. This is going particularly smooth. Let's keep everything the same length, because I hate it when you've got all the wires down there, some of this long, and then you've got to put a connector on. Terrible. So we're going to keep everything the same length, and that way it's going to look pretty. Let's see. Let's collect up what we're going to need next. We're going to need our ignition wire, first of all. That's that red wire with a ring connector on it. We're going to need it for the LCD. We're going to need the constant 12 volt supply we talked about, which is this one. As we go along, untangle them. Take the time now. It's going to make it look a lot better when you've finished up. See how this one's coming through there? Trust me, it's worth just untangling it. So we're going to need TX, RX, constant ground, voltage up, voltage down. That almost rhymed. Look at that. There's our display loom. It wasn't that hard. So let's clip them all the same length first of all. Now I'm clipping these all at the same time because this controller has never been plugged in. Otherwise I would have just sparked off terrible then. Done. Anyone want to sponsor me for cutters, feel free. So that's out the way. What we got? Let's take our ignition wire and start trimming these down. Ignition wire first. RX or TX, can't remember already. Like I said, doesn't matter. I, to be honest, don't even make a point of remembering them. That's how much it doesn't matter. And I like having a 50-50 guess when installing it. It's fun. I usually get one of the kids to flip a coin. You gotta find some joy in it. Right, so there's all our wires trimmed. Let's tart these up a bit. Do this before putting a giant bit of heat shrink on it. If you don't, you end up with nice frayed edges, and then you gotta twist it all back nice and straight once it's on. I'll show you what I mean by heat shrink now. Well, we floated through them. Let's get some heat shrink. That size. We want to fit all these wires in something so it looks neat. I'm trying to look pretty. I like that. Nope, don't like that. Not thick enough. Let's go one up. That's better. There you go. That keeps that nice and neat. Take it as close up to the pin as we can. Hide all the colour. Heat that on. I have no heat gun and I wouldn't turn it on now if I did because of the camera. So we'll just rub this up and down a little bit. Just so it doesn't move, and I'll come back with a heat gun later. I'll do. Now what we got going on? This next, onto our little loom we just made. Nice and easy. Dun, dun, dun. How'd this go? Let me see. We get our heat shrink. We're going to make this so sweet. First one, we cut our alarm off. Remember? This big connector. Constant power. Always in the ground. We're going to use our constant voltage. Without getting technical, they call it on the board the VCC. We're going to connect that to the red of our display, which means our display will always get voltage up and down, which is what we want. Because when we turn the on button on, we want it to send the voltage back down the yellow wire. I think you can see where we're going with this already. One down. Get our heat shrink on. I've already cocked up. Should have added more black up and down. Worry, I'll fiberglass it or something later. I'll take the connector pins out and do it that way. Typical standard day. Anyway, so we got our constant voltage. What else? Let's do our ground. Let's get a ground on there. Heat shrink on the black. Yeah, I'll put heat shrink on now and take these out actually. Because I will have to swap the TX and RX round because I did not write that down. It's not fun. Oh, she didn't settle. That's what I get for rushing, I suppose. Let's get that one on. IAD shrink. There you go. So now we got a constant voltage or VCC, and we got our ground, or as it's marked on the board, GND. I'll run through all these and the abbreviations and mark them down as we run through. Now what do we need? Let's take our ignition wire. Let's put that onto the yellow, because that's what we want to give power as we come back. So that's cool. We're going to need a bit of thicker heat shrink, because the ignition wire is chunky. Not as chunky as the main power cable, but it is chunkier than all the others. That's how we can tell it apart. Without burning myself too much. Cool. That leaves two left. And we have an LCD connector. That's that bridge crossed. I think we'll solder the XT90 on then. And we'll call it a night. In the next video, we will be, let me see, installing this on the vehicle. I'll remove some of the unwanted stuff now before we finish up. And we'll be putting controller 1 on the vehicle, getting the wheel turning the LCD on. And then we'll be prepping controller 2 to be installed alongside it. How to activate dual drive mode and all that stuff. That's nice and easy, so don't panic. Yeah, that's about the gist of it. So let's connect up one of these next. We'll go blue to white was F5. If it's wrong, we just remove the connector pin there and swap the 2 wires around. So it genuinely makes no difference. Nothing blows up. It just shows error 10 on the display, which is a communication error between the controller and LCD, which is like, fair point, mate. I put the wires the wrong way around. Let me switch them. So no biggie. Coincidentally, if you get error 10 on NS866 display, it's because you got a communication error. And if it's because you're not doing this, chances are the cable's broke somewhere along the lines. Check for damage. Quick repair hidden there. So always 1. Oh, come on now. What's going on here? It's a bad wire. Bad wire, bad wire, bad wire. Don't like that. Always 1. There you go. Good wire. And put the shrink on that now. Let's put our last one together. We've got an LCD. Last one in. So yeah, at the end of all of this as well, I suppose I'll be fitting the last parts live stream. Just in case there's any questions, because answering comments is like sometimes a nightmare. I get through as many as I can, but obviously due to the nature of the work, most of the comments are part requests and things like that. I'm not that organised. It involves me trawling through the internet sometimes for hours. Yeah, if I know the answer off the top of my head, I got it in and then. So chances are you get lucky anyway, but I also repair them on the side. Well, full time actually. Phone number should be on the bottom. It's a WhatsApp group number for all my customers. If you're planning on being a customer, feel free to add yourself in. Basically, you might as well. What I covered is motor rewires, motor reconditioning, factory repair, rebuilds, modifications, custom parts, 3D printing, anything crazy that no one else has thought of, that'll do. That'll be a bit of fun. If you want to go 100 miles an hour, great, call me. Yeah, anything that's fun, I'll do. And I also do 9 to 5, Monday to Friday. Regular work, wiring, e-bike repairs, Xiaomi, stuff. So anyway, we've got rid of all of that. What's next? Let's remove some crap. Again, this is not glamorous. We're just desoldering stuff. I'm not going to go through all of it because we're pretty much done here for the night. So this controller is now running where we want it to run. We can now stick it over there onto the vehicle. Let's get a power connector on a second as well. That's a bit of soldering. All these wires might have to be shortened, I'm thinking, actually. No, this will be fine. Let's get an XT90. Go with a 90, 290s. Let's get XT290s on you. instead of XT60s basically. Where is he? Let's get that chunky boy on you. We got an XT90. Nice connector. Some people have trouble fitting them. I can see why. They're a bit of a bugger. Quick way of doing them. There your cables. Flat like that. So when you pre-tin them, it'll don't drip down the end of the wire and drip off. That's no fun. Don't make them too fat. They won't fit in the slots. Literally hold. Make sure it's all tinned. Nice and simple. Same for the next one. Again, nice and simple. Done. Ooh, a bit more tinning. Make sure all the wires absorbed it. Orientation with these is marked. Plus is the squared off edge. Minus is the shaped edge. Like 1/2 of a hexagon, I suppose. Octagon, yeah, one of them. You know what I'm talking about. So we're going to slide that onto where it's supposed to go. Let it fly in the wind. Get a long bit of solder ready because we're just going to run it in there. If you heat up the actual gold clip and not the wire will get hot straight away. Let me see. And you can flood away nice and gently. Lovely. That pretty much is a connection. Job done, never going nowhere. Position yourself up nice for the next one. Put him in exactly the same motion. Heat shrink on first. I haven't. I got another plan for the back of these. I've got special clips that isolates all the wire nicely. They're 3D printed, so I will be using them. Yeah, they're nylon as well, so they go good for temperature. Let's put another bit of this in, because that's not enough solder as far as I'm concerned. I can see a gap. I'm on a clean connection. And keep it cool. 2 seconds. Oof. Hot tamale. Job done. Check the connection. Off you pop. We'll put this back inside this case. There's no need to be inside this anymore. I'm not going to reprogram it. There's no point. Yeah, and we're good to go. Let me zoom the camera back out a second. So next video, this is getting wired up onto the vehicle. We'll get the motor spinning. Can we zoom in a bit? And we'll take it from there. So right, that's that for tonight, guys. 2 nights time, part 2. And we'll be flying down the road. Anyone needs anything, number scrolled up at the bottom. Check yourself into the WhatsApp group, ask your questions. Get to you more than I can on the YouTube comments. And speak to you then.